Hi everyone, my name is Ms. Connolly. I started making videos for my own 5th grade students and decided to make them public for all of you. So make sure you like, subscribe, and share. Let's get as many students learning as possible during this crazy time. So this lesson is for my 5th graders. However, this was taught in 4th grade, so it's review. So if I go through anything too quickly, just know that it was learned in 4th grade, and I'll add some videos to the 4th grade about angles and stuff like that to help you understand even better, okay? So let's get started. We are clearly working with triangles, okay? So triangles are a type of polygon, okay? So if you are in my class, we are gonna start thinking about polygons and how to classify all of these shapes. Polygons are shapes that have many sides, okay? This is one type of polygon, a triangle. And to be a polygon, it has to have the shape has to be closed. There cannot be any openings. And the lines have to be straight. We can't have any curved lines, okay? So a triangle can be defined as a polygon that has 3 sides, 3 angles, and 3 vertices. So a side would be from here to here. There's 1 side, 2 sides, 3 sides. The angle is the space between where the 2 lines intersect, and that's a measurement that you took in 4th grade with the protractors. I'm sure you remember because those are always fun to use. So there's an angle here, and an angle here. So there's our 3 angles, and you can see them here. Okay, and in this lesson, we're going to be talking about the size of angles and how that helps us classify our triangles. We're also going to be talking about the length of sides and how that helps us. And then 3 vertices. So vertices is a plural word for the word vertex. So a vertex is the point where 2 lines meet. Okay, I'm going to draw it on this one so that we can see. So that is a vertex, this is a vertex, and that is a vertex, the point where the lines meet. Since there's more than one vertex, we say vertices, and in each triangle, there would be 3 vertices. Okay, so that's what makes a triangle a triangle. I'm pretty sure that you feel comfortable with that because we learned it since a long time ago. So let's talk about ways to classify triangles. All right, the first way that we're going to classify triangles is by the length of the sides, okay? So the length of the sides, how long each side is, and here's the 3 different ways we're gonna do it. So eyes on the yellow, scalene, and I'm gonna read that word again, scalene. A scalene triangle is a triangle that has all 3 sides with different lengths. So there are no sides that are the same exact length, okay? Next one, pink triangle, eyes there, or pink triangle, pink post-it, eyes there, isosceles, okay? This one always trips us up because it's spelled so funky. Isosceles triangle is a triangle that has 2 sides that are the exact same length. So if we measured 2 of the sides, they would be the same. We call that an isosceles triangle, okay? And eyes on the blue, equilateral triangle has all 3 sides the same length. So if we measured all 3 sides, they would be the same exact length. Now, usually from looking at a triangle, you can tell which sides are the same length and which ones are not. But a little tip is that if you take a piece of paper and you put a dot at one end of where you start at a vertex and a dot at the other one, you can turn it and measure it that way, okay? But for the most part, we can eyeball it and see which ones are the same, okay? So let's take a look at this triangle here, number 12. Okay, we're gonna sort these triangles together. So when you take a look at this, I want you thinking, does it have no sides that are the same length? All 3 sides are different. Does it have 2 sides that are the same length? Or does it have 3 sides that are the same length? And I'm sure by looking at this triangle, you can clearly see that all 3 sides are the same length. So we scoot that right on over to our equilateral triangle category. We can call this triangle, triangle 12, an equilateral triangle because it has all 3 sides the same length. Okay? All right, let me grab triangle 10. Okay, when we're looking at this one, I can clearly see that the length of this side and the length of this side are the same. But this one, I can tell it's not the same. So it has 2 sides that are the same length. So we call that an isosceles triangle. Okay? All right, let's move on to another one. triangle 29, for example. So let's put it down here so we can take a look at it. These two sides look almost similar, but almost doesn't count in this. Okay, so I can tell that this side is quite a bit shorter than this side, and then they're both a lot shorter than this side. So since this triangle has three sides that are different lengths, we call it a scalene triangle. Okay, so what we're going to do is we're going to keep on placing triangles here. Okay, so let's take a look at triangle 11. I'm thinking all three sides are definitely the same. So what is that called, everyone? Say it with me. An equilateral triangle. So we're going to put it over here. Okay, then let's look at triangle 4. Okay, I'm going to look at the sides closely. I can tell that this side is a lot longer than the other ones, but it seems like this side and this side are the same length, which they are. So I am going to call that an isosceles triangle. Okay, let's look at triangle 5. All right, and let me see if I can show you what I meant by marking the pieces of paper. So let's say you have a piece of paper and you're going to mark here and here. Okay, now I can't move a piece of paper on the computer screen, but I can move my triangle. Okay, so I'm going to see if the length of my other side is the same. So you would move the piece of paper. Okay, so is the length of this other side exactly the same from here to here? And it's not. It's a little bit different. So, especially if I move it right on where I marked it, you can see that the one side is just a teeny tiny bit longer. So it is not the same size. So all three sides in triangle 5 are different lengths. So we call that a scalene triangle. So a lot of the times, friends, you can see what's going on just by looking at it, but sometimes you actually do have to do some little measurement tricks if you want to be 100% correct. Okay? All right, number 3, that's one where we can look at it and say, yeah, I'm pretty sure all three sides are the same. So we're going to call that an equilateral triangle. If you're not comfortable looking at it, then measure it every single time. That's okay. And then when you feel more comfortable, then you can just look at it. So triangle 32, I see that this side here is a lot longer than this side and this side. So I'm thinking, yep, definitely an isosceles triangle, two sides that are the same length. Okay? So we just have a couple more triangles to sort. So let's look at number 6. So let's see. At first glance, I'm kind of thinking, oh, maybe they're the same length. So I actually am going to try the measurement trick here. So I'll make a little dot here. Let me turn it and see if I can make it perfect. I'll make, oh, there we go. Okay, so I'm going to measure it. You guys can use a piece of paper. Okay, so that's the length of that side. Okay, so now I'm going to see, are there any other sides that are the same exact length? So let's spin it here, see if I can measure this up. And it does actually look like this side is the same length. But let me try the third one because I can't tell if it's isosceles or equilateral. So I'm going to try to measure it. And I see that third side is a little shorter. So what do we call it if it has two sides that are the same length, only two? That's right. We're going to put it in the isosceles triangle category. Okay? All right, let's take a look at number 1. Can we tell by looking at it that all three sides are a different length? We can. So since all three sides are a different length, we call it scalene. Practice saying the words with me so you can get used to it. Okay? And then when I look at number 7, again, I can tell this one is shorter than this one. And then this side is also shorter than this one. So it has to be scalene. And then shape 30, I can clearly see that this is the shortest side. This one's a little bit longer, but this one is definitely longer than both of them. So all three sides have a different length. Okay, so take a look here at your different triangles. Okay, we have scalene, where all three sides are different lengths. We have isosceles, where two sides have the exact same length. And then we have equilateral, where all three sides are the same. So this is just one way to classify triangles, and it's by the length of their sides. But there's one more way that we classify triangles, okay? It's separate from this, all right? So let's take a look. The other way that we can classify triangles is by the size of their angles, okay? So a right triangle has one angle that is 90 degrees. Okay, I'm gonna go over all of these, so don't worry, we're gonna come back to this. Eyes on the pink here. An acute triangle is a triangle that has all angles that are less than 90 degrees, okay? And then eyes on the blue, an obtuse triangle has one angle that is greater than 90 degrees. And some of us are like, what? I don't know what that means. Well, I'm gonna review with you really fast, okay? And I'll make a video where I go into angle measurement a little more in depth for my fourth grade friends, so we can revisit that too, okay? So I have this little square here to show you what I'm talking about because in case it doesn't make sense with a piece of paper. So a right angle, when we measure inside where these two lines intersect, it will be exactly 90 degrees. What else is exactly 90 degrees? Well, the corner of a piece of paper, okay? In class, you would have had a square tile to fit in there and say, oh, yes, that fits perfectly. And I know that the square tile has a right angle that measures 90 degrees. So I know that I have a 90-degree angle, okay? So since we know a piece of paper always has a 90-degree angle, that's why you're seeing a piece of paper here. So a right angle has a perfect square corner, but in fifth grade, we're gonna say it measures 90 degrees. So a right angle is a 90-degree measurement, okay? An acute angle, on the other hand, is less than 90 degrees, okay? So even though this isn't a triangle, we can still think about angle measurements. You think about angle measurements in a lot of things. So we see that these lines here, the red, intersects here, and so the angle measurement is from here to here. Now, they put this piece of paper over it to show that the angle is not as great as a 90-degree angle. It is less, okay? I'm gonna throw this square on here too to show you how this line goes inside of the square angle, so it's less than 90 degrees. Okay, so acute angle, less than 90 degrees. And finally, we have our obtuse angle, okay? And I put the square in there too to help you see if the piece of paper was confusing. The angle measurement here from this line to this line is greater than 90 degrees because look, we can fit the 90-degree angle in there and there's still this space left over. So when we have an angle that's greater than 90 degrees, we call it an obtuse angle, okay? So these are the three words that we're gonna be thinking about. You've now seen a visual, and I'm gonna use the square tile, the little square 21, to measure some angles to show you. But at home, you might not have a square tile. So what you're gonna do is you're gonna take the corner of a piece of paper, and that's what you're gonna use to measure, okay? So if there's any angles that you're unsure about, you're gonna stick the square corner from your piece of paper in there, and that'll be your measurement to see if the angle is 90 degrees, okay? So whatever I'm doing here with the square tile, you can do at home with a piece of paper. All right, so let's get triangle 1 out here. I'm gonna show you what I'm talking about. I can tell it's a 90-degree angle. I've been practicing 90-degree angles for like my whole life. So, but if you're not sure, you can take your square corner and your piece of paper that is 90 degrees. We're not calling it square corner, I'm just saying if it's a square corner, we know it's 90 degrees is what I'm trying to say. So when I take my square tile and fit it in here, I can tell that the angle measurement is definitely 90 degrees. Since it has one angle that's 90 degrees, okay, and it can only have one because of how triangles are set up, I know I'm gonna call that a right triangle, okay? All right, let's look at this one over here. So if I'm thinking about the angle up here and I wanna see if it's 90 degrees or greater, I'm gonna line up the corner of my tile with the angle there, and there's all this extra space right here. That means that my angle is greater than 90 degrees So I am going to be calling this an obtuse triangle because it has one angle that is greater than 90 degrees. Okay? Then I'm going to show you an example of an acute triangle. Okay? So I can tell that every single angle is less than this right angle here. But in case I'm confused and I can't tell right away, I am going to line up my square tile with the angle, and I see that there's extra space in the square tile, which means that the angle is less than 90 degrees, okay? And I can put that in each corner or in each angle to see, and I can tell that all three angles are less than 90 degrees, okay? If you have all three angles less than 90 degrees, you know that you have an acute triangle. Okay, so those are our three types of triangles when we're thinking about angle measurement. Okay, and now that you're familiar with what they kind of look like, it's easier to see what kind of triangle is which. So, for example, with triangle 4, I can tell that I have a right angle there, so I know that this is a right triangle. Okay, so I'm going to look for my other right triangles. I see triangle 32. Reminds me of triangle 1 as well. And if you're not 100% sure, all you do is you grab your corner of your piece of paper and you put it in there and you say, yep, 90 degrees, okay? Then triangle 31 is also a right triangle. So what do these triangles have in common? They all have one 90-degree angle, so we call them a right triangle, okay? Let's look at my acute triangles. So again, if you aren't sure, you take that square or your piece of paper and you measure your angles. But I can tell here that this angle is less than 90, this angle is less than 90, and this angle is less than 90. So I know that I have an acute triangle here. Okay, I'm going to grab triangle 10, and I can clearly tell that triangle 10 is less than has all three angles that are less than 90 degrees. So less than 90, less than 90, less than 90. And when all angles are less than 90 degrees, I have an acute triangle. Okay? Now, triangle 7 is an acute triangle, but this might be one where you're feeling like I should check it just in case and make sure that it's definitely an acute triangle. And it actually is kind of difficult to tell on here, but there's this teeny tiny little space inside of there, and it actually is slightly smaller, just a little bit smaller than 90 degrees. So in every angles, all the other angles are also smaller than 90 degrees, so we call it an acute triangle. So when all three angles are less than 90 degrees, you get an acute triangle, and here's your examples of acute triangles. Okay? And then last but not least, those obtuse angles that are a little easier to spot all the time. If you have one angle, just one, that's greater than 90 degrees, one obtuse angle, we're going to call that an obtuse triangle. Okay? So what are you going to do at home? Well, you are going to draw me some triangles. Okay? So what I want you to do is get a piece of paper, and I want you to draw a picture of a scalene triangle where all three sides are different lengths. Okay? Then I want you to draw me an isosceles triangle where you have two sides that are the same length, and then the one side is a little different. Okay? And then lastly, for this pink square here, pink directions, I want you to draw one equilateral triangle where all three sides are the same exact length. All three sides are the same length. Okay? So that's one way to classify triangles, is by the length of their sides. The other way to classify triangles is by their angles. So I want you to try drawing a picture of a right triangle where one angle is equal to 90 degrees. One 90-degree angle. Okay? Then I want you drawing an acute triangle where you have three angles. All three angles are less than 90 degrees. Okay, so three acute angles makes an acute triangle. And then lastly, last part of the directions is I want you to practice drawing an obtuse triangle where there's only one angle that's greater than 90 degrees, and we call that an obtuse angle. So try drawing an obtuse triangle. Okay? All right, talk to you later. Bye.